Calibration of CBC analyzer. Calibration is performed to compensate for any inaccuracies in the cell counter relating to pneumatic, hydraulic, electric systems, optic system. This is very important in maintaining the system accuracy. Calibration is the setting or the resetting, that is correcting the base level of a measuring device, testing system or equipment, usually achieved by arriving at a calibration factor by adjusting it to match a traceable measure or calibrator. Calibration is done using a calibrator, which is a material with known value which is traceable through an unbroken chain of comparisons to the true value or SI unit. This is called traceability of calibrator. The calibrators can either have fixed value. A good calibrator will have a definite fixed value with range, as is the case of this machine. This is called the uncertainty of measurement of the calibrator. A cell counter calibration should be done to rectify any issues with accuracy. Before calibration is scheduled, do pre-calibration check. For background check should be within acceptable limits. Precision study. Carryover. Carryover is the residue of a previous test that can affect subsequent tests, and if not, have the tech support deal with this before calibration is ordered. If you are running QCs regularly, review CV percentage of all analytes at all levels before scheduling a calibration. Precision. Since calibrations are fine-tuning the system for accuracy, readjustment can be done only if precision is acceptable. Note, if precision is compromised, errors in the system will remain unaddressed even after calibration.
Precision study in this case can either be intermediate precision as in CV% in IQC or repeatability.
Refer to QC module for details.
Repeatability procedure. Take a sample and run it 10 times. Tabulate the results. Calculate mean, SD and CV for all the parameters. If they are acceptable, check background and carry over.
Background check. This is done to check if there is any interference from conditions that affect the background. Dirty flow cells, dust in the cell pack, bacteria growing in tubings or solutions, lack of grounding, earthing, noise. The manufacturer defines the tolerance limit of different parameters. For more details, refer to the training module on equipment management. If background is okay, check carryover. Carryover testing. This is done to study the effect of the previous run on the current run. Flow cell or cuvettes may contain residual material from the previous runs which can add on to the value in the next run. Procedure for carryover percentage estimation. Run any sample 2 times followed by 3 runs of diluent and apply the following formula. Blank 1 minus blank 3 divided by sample 2 multiplied by 100. Step 1. High value sample run twice. Result 1 TLC 15,000. Result 2 TLC 15,500. Step 2. Run diluent 3 times. Blank first run 1000. Blank second run 400. Blank third run 300. Step 3. Calculate carryover percentage. Carryover percentage is equal to 1000 minus 300 divided by 15,500 multiplied by 100, which is equal to 4.5%. These values are compared to the defined carryover limits of the specific equipment. Some cell counters have built-in options for carryover determination. If it is not available as a built-in option, use the above method. If background, carryover and precision are okay, schedule the calibration. Understanding your calibrator. Calibrators are very expensive and have a short expiry and very low stability. Always ascertain its traceability to ICSH. In the calibrator insert, you can find the target values which are available as a range with the uncertainty of measurements or fixed as in 5-part calibrators. The calibrators are run a fixed number of times, minimum 5, of which the first is discarded and the rest averaged. The mean values of the run are calculated and checked if they fall within the range. In 3-part counters, the values are judged for acceptance by the user. In the event of calibrators with a fixed value, as in 5-part calibrators, the existing calibration factor is automatically modified by the equipment in the calibration mode to new calibration factor so as to match the reference value. If the adjustment is too much, the equipment will flag and the user can decide to accept or not. Calculation. New calibrator factor is equal to reference value minus obtained value multiplied by old calibrator factor. Interpretation of calibration. Acceptability is generally defined in the operator's manual. Factor difference percentage is the difference between the old calibrator factor and the new calibrator factor expressed as a percentage. That is, new calibrator factor minus old calibrator factor divided by old calibrator factor multiplied by 100 is equal to factor percentage difference. The results are judged for acceptability. In the case of this equipment, which provides a range due to the uncertainty of measurements of the calibrator, if the average falls within this limit, the calibration is accepted. In fixed calibrators, the factor changes should be documented. Once the new factors are accepted, equipment is calibrated. Manual manipulation of factors is self-defeating and should be avoided. Frequency of calibration. Calibration has to be performed at fixed intervals. NABL recommends annual calibrations. However, in an old equipment, it should be more frequent. 5-part cell counters generally have 2 modes: cap piercing or auto or primary modes, open or manual or secondary modes. Depending upon how many modes your machine has, remember both modes need calibration. Post-calibration verification. After successful calibrations, verification is needed. Run QCs. At least 2 levels of QCs should pass. Repeat the precision check, to be done in both modes if 2 modes are available. Documentation of calibration. Before calibration, CV% of QC, carryover data, precision repeatability check data, background check. Post-calibration documents, raw data, adjustment factors data, QC verification, calibration insert with traceability, certificates and reports, factor change documentation.